Hey guys, Travis here. Gobble Gobble. We're on Tuesday of the Gobble Week. Hopefully, I have a lot to be thankful for, guys. Thank you guys for coming in here and checking out this video. It might be after Thanksgiving that you're watching this, and that's okay. All right, so hopefully, if it is Turkey Week, I hope that you are relaxed and doing fine and loving life. And if it's past Turkey Week, well, welcome back. Sorry that you have to watch this video. Hopefully, you're happy. All right, let's get going, and here we go, guys. Question one. It says the length of a rectangle increases at a rate of 0.5 centimeters per second. So I'm going to draw a rectangle real quick. So here's my rectangle, and I like to go by x and y. So if I see a horizontal displacement, I'm going to call that x. If I see a vertical displacement or a vertical segment, I'm going to call that y. Let's see. The length of a rectangle increases at a rate of 0.5. So I'm going to call x my length. So that means my dx dt is 0.5 centimeters per second. And the width decreases at a rate of 0.5 centimeters per second. So I'm going to call y my width. So my dy dt is decreasing. So it's going to be a negative 0.5 centimeters per second. At the time when the length is 10, so when x is 10, centimeters and the width is 7 centimeters, so 7. What is the rate of change of the area of the rectangle? Okay, guys, so to get full credit, you got to show me area first. Area is x times y. And then we're going to take a derivative with respect to time. So dA dt equals first times derivative of the second, dy dt, plus second times derivative of the first, the dx dt. Now, some of you, I think there's at least two of you that you didn't show me any of this. You just did like 10 times 0.5, plus 7 times a negative 0.5, and those are all the values that you have, and you got it right. But guys, you got to show me this. I didn't give you credit, or maybe I did. I can't remember now. If I did give you credit, it was very little because we had to see this, guys. If this were a free response question, sometimes there's a point tied to getting the ZADT, and there's something called the bald answer. If you just show an answer without showing where you derived it from, sometimes they won't give you any points on a free response. So you got to show me that, guys. So here it is, dAdt evaluated when x is 10 and y is 7, or I guess you can just type it right in, right? Because there's too many variables there. So x, 10 times dy dt, negative 0.5, plus y, 7 times dx dt, 0.5. So there it is. Let's see, half of 10 is negative 5. And then half of 7, what's that, 3.5? 7, 3, 3, 6, yeah. So 3.5. And the difference between negative 5 and 3.5, what's that? Negative 3, 4, well, negative 1.5. So negative 1.5. And then I need units, square centimeters per second. You can always type that into the calculator because it does say calculator here, but I don't think you need it. Let me know. I make mistakes all the time, guys, so let me know. All right, question 2. If sine xy equals x and dy dx equals, all right, so the first thing you got to do, guys, there's still some of you that are saying y equals this. There is no y equals. You got to do this implicitly, guys, and it must be implicit. If you said y prime equals right off the bat, I'm going to dock a point for that, guys. So you got to take the derivative of sine, which is cosine of xy, and now you take the derivative of the inside, guys. So now we're going to take the derivative of this inside. You got to leave that xy there, guys, because that's the argument, right? So cosine xy, and then I'm going to do the derivative of the inside. So first times derivative of the second. We're taking derivative with respect to x, not y, not t. I was about to write t. First times derivative of the second, dy dx, plus second times derivative of the first, close, equals, and the derivative of x is just 1. I don't see any issues. Let me check. Yeah, we're good. So we're going to go ahead and distribute. And I guess you can make a point for dividing by cosine xy, but then you're going to have to do a common denominator. So I think this is the easiest route. X dy dx cosine of xy plus y cosine of xy equals 1. So there it is, guys. Your xy is your argument, so hopefully you put it attached to that. If you're still having confusions, please talk to me, guys. Move that y cosine xy to the right. X dy dx cosine of xy equals 1 minus y cosine of xy. And then we're going to divide, this is all a product, right? X times dy dx has cosine xy. So you're going to divide by x cosine xy. So you're going to have dy dx equals 1 minus y cosine xy over x cosine xy. And then there it is. I don't see any issues. I think we did that correctly. And here it is, guys. Yay. All right, question 3. Oh, 3, 4, 5, and 6. I guess we'll take care of this really quick. There's an exponential function, guys. Remember the derivative of an exponential. I'll go ahead and write it here for you. A to the power u is equal itself, a to the power u ln of a times du dx. That's the definition. So a lot of you be careful. You don't bring the x squared down. There's not a power rule. You have a variable in the exponent, guys. So there's an exponential. So derivative of this 5 to the power x squared is itself 5 to the x squared. And then you're going to go ln of what? ln of 5. And then you're going to multiply by the derivative of x squared, which is 2x. You do not multiply the 5 times the 2. You can't do that, guys. Some of you guys are telling me 10. You can't do that. This is an exponential function. This part right here is exponential. This part right here is linear. You cannot multiply those. You're breaking the rules of math and physics. So there it is. Leave it alone. We're done with that one. So the same thing with this, but this is an e, so even better, right? So d dx of e to the u is itself e to the u times du dx. If you're wondering, Chuck, what happened to the ln? Yeah, you could have done it. You could have said d dx of a to the u is itself a to the u ln of a times du dx. You could have done that, guys, but ln of e is just 1. So do you see how it just works? If I were to plug in ln of e is 1, ln of e is 1. So you would have had e to the u times du dx anyways. So here we go. Derivative of e to the sine x is itself, e to the sine x, times derivative of sine x, which is cosine x. So if you wanted to rewrite it, you can. Cosine x, make sure that parentheses around the x there, e to the sine x. And that's it. I guess you could have also written this in the front, e to the sine x, and then put the cosine x down here, which I guess would have been that right there. Excuse me. I had a big breakfast, so that was a hiccup from that. All right, there it is, guys. Let's go to this one. There's the derivative of arc sine. I'll go ahead and write the rule right here in the top. d dx of arc sine of u is 1 over square root of 1 minus u squared times du dx. So there it is, and that's all we're going to do. We're just going to do that. So 1 over square root of 1 minus parenthesis 3x squared, close it, squared, times the derivative of 3x squared, which is 6x. So some of you tried to simplify, but he simplified incorrect. 6x over square root, if you're going to square it, 3 squared is 9, so 1 minus 9, x squared squared is x to the 4th. So there's your law of exponents. I don't see any issues. We're good. You could have left it with this 3x squared there. Not a big deal. So again, this one right here, guys, d dx of arctan of u is 1 over 1 plus u squared times du dx. So there is my rule. And I'm just going to use my rule, guys. 1 over 1 plus parenthesis 2x cubed, close it, squared, times the derivative of 2x cubed, that is 6x squared. I don't see any issues. I think we're good. You could have left it alone right there. 6x squared over 1 plus. You could have left it with the 2x cubed with the square there. But if you're going to square it, 2 times 2 is 4. And x cubed squared, that's going to be x to the 6. And there it is. We're done. All right. Let's see what we got next. The points 1, 1, 2, 3, 3, 13 are on the graph of the function f of x equals x cubed minus 2x squared plus x plus 1 for x greater than 1. The function g, okay, so they're being nice. So if I plug in a 1 here, they're saying that f of 1 equals 1. They're saying that f of 2 equals 3. And they're saying that f of 3 equals 13. So let's check. I'm just going to plug in a 2. 2 cubed is 8. 2 squared is 4. 4 times 2 is another 8. Plus 2 plus 1. Yeah, that's a 3. 2 plus 1 is 3, and these zero out. So yeah, it works. So there it is. If the function g is the inverse of f, so g is the inverse of f, then g prime of 3. Okay, this is a y value on f of x. So that means I should be paying attention to this guy right here. So focus on f of 2 equals 3. So that means find f prime of 2. Whatever the derivative of 2 is, g prime of 3 is just going to be the reciprocal of that. So g prime of 3 is equal to 1 over f prime of 2. If you don't understand this, guys, please look at my video about inverses. I forgot the notes, but look at my video. Just rewind until you see inverses, inverse functions, and we talk about why this is, guys. If you still have questions, please come see me. Come talk to me. All right, so I'm going to find f prime of 2. So I'm going to take a derivative. So here it is, f prime of x equals derivative. The derivative of x cubed is 3x squared minus the derivative of 2x squared is 4x plus 1. All right, f prime evaluated at 2 is 3 times 2 squared minus 4 times 2 plus 1. So 2 squared is 4, 4 times 3 is 12, minus 4 times 2 is 8, plus 1. 12 minus 8, that's 4, plus 1, I got 5. So f prime of 2 equals 5. So g prime of 3 equals 1/5. It's just a reciprocal of whatever you get there, guys. So there it is. If you don't understand that, guys, please see me. Please come see me. All right, so the derivative of this one. All right, so let's do it. So this is arctan. So quick side note, d dx of arctan of x e to the x. That's going to be, well, I meant to say arctan of u. And then you're going to have to do product rule, looks like maybe. Derivative of arctan of u is 1 over 1 plus u squared times du dx. All right, so let's see what this is. I'm going to go y prime equals, this is arctan, so 1 over 1 plus parenthesis x e to the x, close it, squared times, and insert because we're about to do product rule. So you want to make sure to insert it, because if you don't insert it, when you put the plus, it looks like you're just multiplying that, and it looks like you have a whole brand new term. So you must insert parentheses or brackets or whatever it is, whatever method you prefer. First times the derivative of the second, the derivative of e to the x is itself, plus second e to the x times the derivative of the first, which is just 1. See, if you don't insert these parentheses, guys, it looks like, look what happens if I delete this parentheses. It looks like you're just taking this times x e to the x, and then this is a whole brand new term. So you must insert parentheses there. Must. All right, I think we got it. So here we go. Y prime equals x e to the x plus e to the x. So that's like my numerator there. 1 plus, and then if I'm going to square it, law of your exponent laws, law of exponents, x squared e to the 2x. And I look for that. And here it is. Yay. What's going on with my marker here? All right, let's see. What do we got next? The bonus. Okay, so here's what I had to see for the bonus, guys. I'm going to write this as y equals. Do I have plenty of space down here? Yeah, I probably do. So I'm going to write y equals x to the 5th, x minus 1 to the 3rd over x plus 2 to the 3rd, x squared plus 1 cubed. It does say logarithmic differentiation. So whatever you do to one side, you do to the other. So I'm going to write ln of that. I'll put ln of all this. So now, so here's what I have. I have ln of y equals, and I have ln of all this, but look, there's a minus sign, so or division, so that means, let me do a side note. ln of a over b equals ln of a minus ln of b. So that's what I'm doing right there, guys. So I'm going to go ln, giant parenthesis, x to the 5th, parenthesis, x minus 1, close it, cubed, close, minus, see, it says minus there, ln of x plus 2 cubed, x squared plus 1 cubed. So that's what I wanted to see there. And then I have a product here, see? So now I'm going to do this other rule, ln of AB, that's just ln of A plus ln of B. If you're wondering where do these rules come from, logarithm are exponents. They're like exponents, so when you multiply exponents, you add them. So there it is. That's where this is coming from, guys. Remember, they're just inverses, right, of exponents here. So here we go. I'm going to write ln of y equals, and I have a product there. So I can rewrite this as ln of x to the 5th plus ln of x minus 1 to the third. I don't see any issue. I think we're still good. Minus, let's see, minus what do we got? ln, and then I got another product here, so I'm going to go ahead and put parentheses right here because I'm about to do put a plus there. ln of x plus 2 cubed, close it, plus ln of x squared plus 1 cubed, close that, and you can see we're going to distribute that negative, right? So now I'm going to have ln of y, and I don't see any issues. I think we're still good. Yeah, we're still good. I'm going to move this 5 to the front. That's a power rule of logarithms. 5 ln of x, and I guess you could have left it there if you wanted to, but it makes life a lot easier. 3 ln of x minus 1 minus ln, well, I guess let's move the 3, right? Let's move that 3 out of there. So 3 ln of x plus 2 minus, because we're distributing that negative, 3 ln of x squared plus 1. I don't see any issues now. I think we're still good. So let's go ahead and take a derivative. So 1 over y, but that's not an x. I'm taking derivative with respect to x. So dy dx equals 5 times 1 over x plus 3 times 1 over x minus 1 minus 3 times 1 over x plus 2 minus 3 times 1 over x squared plus 1. So there it is, guys. Now I'm just going to multiply by y, so I'm going to have dy dx equals, and I'm going to write y, giant parenthesis, 5 times 1 over x is just 5 over x, plus 3 over x minus 1, minus 3 over x plus 2. Ooh, did I forget something? I did. An error right here. This is x squared plus 1, so chain rule, 1 over x squared plus 1 times 2x. So there it is. So that's going to be minus 6x over x squared plus 1. I don't see any issues. I think we took care of our mistake there. Yeah, we're good. Now remember that y equals, look what I had here in red, y equals x to the fifth, x minus 1 to the third over x plus 2 to the third, x squared plus 1 to the third. So this is what y equals. That's what I'm going to substitute. So that's what I'm going to sub for that y there. So now finally I have dy dx equals, and let me zoom out so I can catch that again, x to the fifth, x minus 1 to the third over x plus 2 cubed, x squared plus 1 cubed. Giant parenthesis. All right, so now 5 over x plus 3 over x minus 1 minus 3 over x plus 2 minus 6x over x squared plus 1. And there it is. And I look for that. X to the fifth. 5 over x plus 3 over x minus 1 minus. It looks like it's letter E. I don't see any issues. I think we're good. Yeah, we're good. All right, you must have had that work, guys. I can't give you the credit if you just circled E, because I know some of you are really good test takers, and you can just look at the patterns and be like, well, I did the UH quiz, and based off of those patterns, so we can't play that game, guys. We gotta stop. All right. I hope you guys are happy. Sorry if you feel that I'm being really picky, but I have to, guys. I have to. The table to the left gives values of functions g and its first derivative g prime. First elective values of x. The function f is defined by, so they tell us how you're defined. So they want f prime of x. Well, here's f of x. So I'm going to go ahead and put a first, second. F prime of x equals first. Let me go ahead and make that equal sign a little better. X minus 2 times root of the second, e to the x, plus second, e to the x times root of the first, 1. And I guess factor out an e to the x. And if you factor out an e to the x, you're going to get x minus 2 plus 1. So e to the x and negative 2 plus 1, that's minus 1. So x minus 1. And you don't have to, guys. You didn't have to do that. You could have left it alone right here. But I think it's just easier. And I'm going to go ahead and take another derivative. So I'm going to go ahead and underline this one first and underline that one second. So first times root of the second plus the second times root of the first. And again, I'm going to do the same thing. I'm going to factor out an e to the x. I mean, you don't have to, right? E to the x, and you're going to get 1 plus x minus 1. And then those ones cancel out. And then you just get e to the x times x. And you could have left it alone like that. And there it is. That's it. Let h be the function given by, so they give you, and they want you to find h prime of 3. So you're going to have to do chain rule, guys. H prime of x is equal to the derivative of the outside, g prime, leave the inside alone, times derivative of the inside, g prime of x. All right, so there it is. I'm going to go ahead and find h prime. Sorry, let me get rid of this little thing here. H prime of 3. So g prime of g of 3 times g prime of 3. So let's see, g of 3. So g of 3 is 1. So g prime of 1 times g prime of 3. All right, g prime of 1. So I go to 1, and g prime of 1 is negative 1. So negative 1. And then g prime of 3. G prime of 3 is 2. So negative 2. So there it is. H prime of 3 equals negative 2. Let me check how calibrated. It's a little off. That's fine. It's a little off, like maybe a millimeter. Well, it's yeah, probably about a millimeter off. All right. Let k be the function given by. So again, guys, it's just chain rule. K prime of x equals derivative of the outside, f prime. Leave the inside alone. You have, what do you have? G of x squared. Close it. So remember, it's g of x that's being squared times derivative of the inside, 2 g of x, close to the power 1. Leave that inside alone times g prime of x. Whew, that was a pickle. So we're going to go ahead and plug in a 2, guys. K prime of 2 equals f prime of g of 2, close, squared, close it, times 2 times g of 2, close that. Yeah, we're still good. I don't see any issues. Times g prime of 2. All right, let's see. F prime and then g of 2 is 3. So g of 2 is 3. This guy right here, that's 3. So 3 squared is 9. So f prime of 9 times 2 times, so let me see, make sure I close everything correctly, times 2, g of 2, what did we say? Well, that was 3 times g prime of 2. So 2 times 3 is 6. So I'm going to write it like this. 6 f prime of 9 times g prime of 2. So let's see, 6 times f prime of 9. Do I have f prime of 9? Nope, but I can just plug it in here. So I'm going to put that on the side here. F prime of 9 equals, so let's see, e to the 9 times 9 minus 1, which is 8. So 8 e to the 9th. All right. So I'm going to come back. So 6 times 8 e to the 9th, and we'll figure all that right now in a little bit, times g prime of 2. I think we didn't know we did it. Or maybe we did, but I just can't remember. No, I haven't seen that. G prime of 2 is negative 3. So let's see what I see. So negative, I guess if I go 6 times negative 3, that's a negative 18 times 8 e to the 9th. And I guess I'm just going to go ahead and do 18 times 8 here on the side. 8 times 8, 64. 64. 1 times 8 is 8. 8. 9, 10, 11, 12, 13, 14. So 144. Negative 144 e to the 9th. And there it is, guys. All right. This is from the notes. From notes directly. What is the slope of the line tangent to the curve y equals arctan 4x at the point which x equals 1/4? So we're just going to go, let's see. I'm just going to take the derivative of arctan. So let me go ahead and write here let me go ahead and give you the derivative first. D dx of arctan of u, 1 over 1 plus u squared times du dx. So that's all I'm going to do, guys. So y prime equals 1 over, this is my u, 1 plus 4x close it squared times the derivative of 4x, which is 4. I don't see any issues. 1 plus, I'm going to leave it as 4x, guys. All right, I'm going to insert 1/4 right there. So y prime evaluated at 1/4 equals 4 over 1 plus 4 times 1/4 is 1, and 1 squared is 1, see? So there it is. All right, let's continue. Consider the curve given by the equation y cubed minus 3xy equals 2. So again, implicit. So we're just going to take a derivative. So we're going to go 3y squared dy dx, I'm taking derivative with respect to x, minus, and then do product rule with this. I guess you can leave the 3 on the outside, but I already grouped it there, so I'm going to leave it. So first times derivative of the second, plus second y times derivative of the first. Oops, just 3, because I put the negative on the outside. Let me make sure, y times 3, yep, equals 0. The derivative of 2 is 0. Distribute. So I have 3y squared dy dx minus 3x dy dx minus 3y first under the second plus second under the first. Yeah, I don't see any issues. Equals 0. I'm going to move the 3y to the right. So I have, let me write it over here. I have 3y squared dy dx minus 3x dy dx equals 3y. And I'm going to factor out a dy dx. So dy dx equals, let's see what we got. 3y, well, okay, I was going too fast. Let me dy dx just 3y squared minus 3x. 3y squared minus 3x equals 3y. And now divide. Dy dx equals 3y over 3y squared minus 3x, which is, if you factor out a 3 on both of them, y over y squared minus x. And there it is. I don't see any issue. I think we're good. Write an equation for line time to the curve at the point 1, 2. Use this tangent line to approximate y equals x. To approximate y when x is 1.3. Approximate value of correct is bonus. Okay, so I gave you a bonus for that. All right, so tangent line. So I need a point and a slope. So dy dx evaluated at 1, 2 is nothing more than 2. I'm just doing this right here, guys. 2 over 2 squared minus 1. So 2 over 4, 2 squared is 4, 4 minus 1 is 3. 2 over, yeah, I don't see any issues. All right, so here we go. Y minus 2 equals 2/3, parenthesis, x minus 1, close it. I want to approximate 1.3, so that's what I'm going to plug in right there. So tangent line. All right, here we go. Y is approximately 2/3 times 1.3 minus 1 is 0.3, guys. And then plus 2. All I did, that plus 2 comes from that one, move that way. So that's where it comes from. That's where that plus 2 comes from. All right, 0.3 is the same thing as 3/10. Let me make sure, yep. So I'm going to rewrite it. 2/3 times 3/10 plus 2. I see these 3's canceling out like that. So I see 2 over 10. See? What's going on right there with that little? I see 2 over 10. So 2 over 10 plus 2. And remember, 2/10, that's the same thing as 1/5. So I see, let's see, I see 2 and 1/5, or 11 over 5. 2.2. Let me make sure that I didn't make any mistakes. I don't see any. 1/5 plus 2, 2 and 1/5. Yeah, we're good. There it is. All right, second derivative. Let's see, where are you? Okay, so second derivative, I'm going to take a derivative of that guy. So let me write it first. Dy dx equals y over y squared minus x. And they want it at 1, 2. Remember, guys, I already got my slope at 1, 2, or the value of dy dx at 1, 2. So I'm going to go d squared y over dx squared equals bottom y squared minus x under the top, dy dx, minus the top times rid of the bottom, 2y dy dx minus 1, all over bottom squared. All right, I don't see any issues. Let's just plug in numbers. I would just plug in numbers. So d squared y over dx squared evaluated at 1 comma 2. So y squared, so remember y squared is the y value. Well, y squared is the y value, obviously. 2 squared 4, 4 minus 1 is 3. So I see 3 times dy dx, we got that as 2/3, minus y, which was 2, times 2 times 2 times 2/3 minus 1. So hopefully I didn't make a mistake right there. All this is over, let's see, 4 squared minus 1, 2 squared, 4 minus 1, 3. So 3 squared is 9. All right, and this is all like that. All right, let's see. So if I didn't make any mistakes, those are out. I don't see any issue. I think that's good. And so I see, let's see, 2 minus 2 times 2 is 4. 4 times 2 is 8. So that's 8. And hold on, I don't want to make a mistake here. That 2 is that 2 there on the outside. So 8/3 minus 1. So I see 2 times 8/3 minus 1. And then that 1 I'm going to turn to 3/3. So 8/3 and 3/3. 8 minus 3 is 5. So I see this as 5/3 all over 9. So 2 times 5 is 10. 2 minus 10/3/9. So I'm going to turn that 2 into 6/3. And I don't see any issues right now. 6 minus 10 is -4. So -4, and then 9 times 3 is 27. If I didn't make any issues or mistakes, it should be -4/27. And that's it, guys. I did it. So that's just arithmetic. With time, you just kind of get better. Just don't confuse that 2 there. Maybe, these parentheses here in blue is this here in blue. I don't see any issue. I think we're good. Okay, I think we're good, guys. No, it looks good. Okay. And we still got, well, really, this is where we have issues on question 13. Not extreme, but we got some issues. So let's see. Ship A is traveling due west towards Lighthouse Rock A at the speed of 15 kilometers per hour. All right. So ship A is traveling that way towards the lighthouse. Ship B is traveling due north. So ship B is traveling that way. See? Ship B is traveling due north away from Lighthouse Rock A at a speed of 10 kilometers per hour. Let x be the distance between ship A and Lighthouse Rock at time t, and let y be the distance between ship B and the Lighthouse Rock at time t, as shown in the figure to the right. All right, guys, so here's my grid. So that means this coordinate right there is going to be 0, 0. So this is like my y-axis and my x-axis. So I don't see any issues so far. Let's see. Find the distance in kilometers between ship A and ship B when x is 4 and y equals 3. So here's x. So this is x, here's y, and then they want this guy. So it looks like if x is 3 and if y is 4, then that means the distance between the ships has to be 5. But if you don't see that, so I'm going to write, what am I going to do? Pythagorean theorem. 3 squared plus 4 squared equals z squared, where z is the distance between ship A and ship B. So 3 squared is 9, 4 squared is 16, equals z squared. 25 equals z squared, square root, z equals 5. And not just 5, make sure to put units, 5 kilometers. All right, there it is. I don't see any issues there. Find the rate of change in kilometers per hour, the distance between the two ships when x is 4 and y is 3. X is 4. So I got these confused. Sorry, guys. We got lucky. Well, not really, because it was still going to be Pythagorean theorem. So, but yeah, we're still good. X is 4 and y is 3. Find the rate of change in kilometers per hour. Okay. So again, we're doing Pythagorean theorem again, guys. X squared plus y squared equals z squared. And what they want find the rate of change in kilometers per hour, the distance between the two ships. So they want dz dt question mark, and we can't use a calculator yet. So we're taking the derivative with respect to t, guys. 2x dx dt plus 2y dy dt equals 2z dz dt. You can factor out a 2 and cancel them all out, so you can just get rid of the 2's there. And I like to just plug in. So remember that x is 4, y is 3. These are all kilometers. The x dt is the x dt. That's the ship here, and it's going towards. So it's going to be a negative. Let's see what it was. Trip A is traveling due west towards light. So it's traveling west, a lighthouse rocket at a speed of 15 kilometers per hour. So that is a negative 15 kilometers per hour. So a lot of you got it wrong because you didn't put a negative there. It's traveling towards the left, guys. dy dt is that one's going north. That's going to be a positive. And dy dt is going 10 kilometers an hour. So I think we got everything, guys. I'm going to plug in. Let's see. 4 times negative 15 plus 3, that's what y is, times 10 equals 5 times dz dt, which is what we're looking for. dz dt. All right, so 4 times negative 15. 15, 30, negative 60. So negative 60 plus 30 equals 5 dz dt. So that means negative 30 equals 5 dz dt. And if I divide by 5, dz dt equals negative 30 divided by 5. So I believe that is 6. 5, 10, 15, 20, 25, 30. Yep. dz dt equals negative 6. And per units, kilometers per hour. All right, so there was the key, guys. Make sure you put negative 15 because it's heading, here's the origin, 0, 0, and you're heading left on that. So that's important. Make a grid. Make sure that you guys are aware of that. Let theta be an angle shown in the figure. Find the rate of change of theta in radians per hour when x is 4, y is 3. Okay, so here's theta. We're looking for that. So make a relationship between theta, y, and x. So I'm going to write SOHCAHTOA. So let me go ahead and remake that grid. Here's theta. That point there is 0, 0. This is x. This is y. All right, SOHCAHTOA with respect to tan. So tangent of that angle is y over x. I would just do it right here. You can do the inverse of that, but you're going to have to do quotient rule anyways because you got to do it with respect to t. So I would just leave it right here and then just take the derivative with respect to theta, right? Because that's what they want. Find the rate of change of theta. So they want. So let me write what they want. They want d theta dt. That's what they want, guys. And I think we have enough experience with that. I mean, maybe we haven't done a lot of these, but we should know that that's what they want. The derivative of tan is secant squared. So I'm going to write secant squared theta. And then they want the derivative. I didn't take the derivative of that with respect to t. I took the derivative of that. Hold on. I took the derivative of that with respect to t. Now with respect to theta. So on the side, you just write d theta dt. Chain rule, right? That's all it is. There it is. And then I'm forced to do quotient rule. There's no way around it. Bottom times derivative of the top minus the top times derivative of the bottom all over bottom squared. So there it is. I'm just going to plug in. Guys. Chubb, I don't know what secant squared is. Yes, you do, because you know that x is 4 and you know that y is 3. And you know if I put a z there, and you know that z is 5. And secant is just a reciprocal of cosine. So if cosine theta, let's see, cosine theta would have been 4/5, right? X over z. So that means secant theta is 5/4. See? So there we go. I'm just going to plug in, guys. So I'm going to write, let's see, what am I going to write? I'm going to come over here. I'm going to write 5/4 squared d theta dt equals x, which was 4, times dy dt. dy dt was 10 minus y, which is 3, times dx dt, and dx dt was negative 15, all over x squared, and x was 4, so 16, because 4 squared is 16. So let's see what I get with this right here, just with this part right here. Why isn't it writing all the time? Okay. All right, 4 times 10 is 40. And then 15 times 3, 15, 30, 45. So minus a negative, so plus over 16. So let's see, 40 plus 45, that's 85 over 16. Okay, I'm going to leave it like that. I don't see any issues with that. So I have, and I'm going to square this. 5 squared is 25 over 16. So d theta dt equals 85 over 16. And then I'm going to get rid of this by multiplying by the reciprocal. 16 over 25 times 16 over 25. All right, here we go, guys. The 16s cancel out, 25s cancel out. So I have d theta dt equals, the 16s cancel out again, 85 over 25. Since I see that they're both divisible by 5, I'm going to count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. Maybe I didn't have to do all that. 17 over 5, 10, 15, 20, 25. 17 over 5. I don't see any issues. Let me make sure. We're good. I think we're good, guys. So there it is. Radians per hour. All right, let's keep going. Now it says we need a calculator, but I don't really think we need one. Let's see. The radius of a sphere is decreasing at a rate of 2 centimeters per second. So that's a radius. So dr dt equals negative 2 centimeters per second. At the instant when the radius of the sphere is 3 centimeters, so when r is 3 centimeters, what is the rate of change in square centimeters per second of the surface area of the sphere? So area. Area of the sphere is 4. I don't like the S. I'm going to change it to A. 4 pi r squared. That's area of the sphere. All right. So they want the rate of change. Let me make sure. What is the rate of change in square centimeters per second? So they want me to take the derivative of this. And I can see that my pen is not working the way it should. Yeah, see, there's little gaps. So, all right. So here we go. dA dt equals 8 pi r dr dt. So 8 times pi times 3 times dr dt, which is negative 2. So 8 times 3, 8, 16, 24. 24 times 2 is 48, so negative 48 pi. We didn't need a calculator, but it says we could use a calculator if we wanted to. And finally, the last one, the graphs of f and g are shown on the right. So I have to use product rule, it looks like. So h of x, or h prime of x is equal to first times derivative of the second plus the second times derivative of the first. And we're going to find it at 6. So here's f, here's g. So before I find all that, I guess I'm going to have to find all these values first. So I'm going to write f of 6 equals, so here's f, 1, 2, 3, 4, 5, 6. Here's 6. So f of 6 is 2. And then f prime of 6 is, so let's see, here and here, 1, 2, 1, so negative 2. G of 6 is, here's G, so G of 6 is 1, 2, 3, that looks like 4 to me. And G prime of 6 is, let's see, 1, 1, 2, negative half. So these are just slopes. Slope of f and slope of g, because it wants g prime of 6, right? So here it is, guys. H prime of 6 equals f of 6 is 2. G prime of 6 is a negative half. Plus g of 6 is 4. And then f prime of 6 is a negative 2. So negative 1 minus 8, so negative 9. All right. Hook it up with a thumbs up if you felt like it helped you or this helped you. And gobble gobble, guys. All right. Talk to you guys later. Bye.